In this section, we're going to talk about the strategy pattern. Let's say in our imaginary application, we want to have the ability to store the images that our users upload. So let's add a new package, strategy. And in this package, we add a new class called image storage. This class is going to give us the ability to store the images that our users upload. So here we need a method, public void store. We give it a file name. Now, as part of storing an image, there are a couple of things we need to do. First, we need to compress that image using one of the image compression algorithms. So as you probably know, we have different types of image compression algorithms like JPEG, PNG, and so on. So first, we want to compress the image to reduce its size. And then we want to apply a filter so all these images have a common look. Perhaps we can apply a black and white filter or a high contrast filter, and so on. So here we need a couple of private fields that determine the type of compression algorithm and filter we're going to use. So private string compressor. Now here I'm using a string. It would be better to use an enum because here we're dealing with a set of constants. But let's not worry about that detail. I don't want to waste time creating an enum. A string is sufficient for now. We need another field called filter. Now we can initialize these fields using a constructor. So let's quickly generate a constructor with two parameters to initialize these fields. Take a look. So we have two parameters, compressor and filter, and we're initializing our fields using these parameters. Beautiful. Now we can implement the store method like this. If compressor equals JPEG. Now here we're going to call a method to compress this image using the JPEG algorithm. But in this demo, we don't want to worry about that detail. We just want to print a message like compressing using JPEG. Else if compressor equals PNG. Then we're going to print a different message, compressing using PNG, and so on. Now we could support many other compression algorithms. Let's not worry about that at this point. Next, we should apply a filter. So we need another set of decision-making statements like this. If filter equals black and white, we print a message like applying black and white filter. Else if filter equals high contrast, we're going to print applying high contrast filter. Now, there are a couple of issues with this implementation. And at this point, you should be able to tell what those issues are. Can you pause the video and think about this for a few seconds? Here's the answer. The first problem is that this method, or more accurately, this class, is violating the single responsibility principle. Because with this implementation, this class is not only responsible for storing an image, it's also responsible for compressing an image and applying a filter. So here we have a simple print line statement, but as I told you before, instead of this statement, we would have a call to a method that would compress this image using the JPEG algorithm. And that method would probably be 10 or 20 lines of code, if not longer. So as we support different image formats, our class is going to get bigger and bigger, and this will make it really unmaintainable. We have the same problem with applying a filter. The more filters we support, the more bulky our class will become. So we are violating the single responsibility principle. The second issue is that it's difficult to support new compressors or new filters. Every time we want to support a new filter, we have to come back here, make a few changes in different parts of this class, and over time, this will get harder and harder. Now, you know the four essential principles of object-oriented programming: encapsulation, abstraction, inheritance, and polymorphism. Which principle do you think we can apply to solve this problem? You should know the answer. So I want you to spend 10 to 15 minutes on this and propose a solution. We'll look at my solution next.